Every day, solar radiation streams down on Earth's surface. As the land and the oceans warm, they radiate some of their heat back out into the atmosphere. Some of that heat is then trapped by naturally occurring gases like water vapor, methane, and carbon dioxide. It's called the greenhouse effect. And for millions of years, it's kept Earth's climate livable. But why is the greenhouse starting to get too warm? The answer is that the sun which warms the greenhouse also fuels a process that cycles carbon from the atmosphere and stores it underground. Author Thom Hartmann calls it current and ancient sunlight.
Through the majority of human history, we lived on current sunlight. Sunlight falls on the ground, stimulates plant growth. Plants trap that energy, the heat energy from the sunlight, through photosynthesis to form carbohydrates. And we would eat that, or we would eat animals that ate that. They ate current sunlight. And then, more or less largely about 1,000 years ago, in some parts of the world, we started using sunlight that had been trapped in the earth hundreds of thousands to millions of years ago, primarily coal. And that was the beginning of the use of ancient sunlight, sunlight that had been trapped by plants a long time ago and buried in the earth. Now we're liberating that carbon into the air as we burn this ancient sunlight, as we burn these fossils. And we're moving in the direction of returning the atmosphere toward the way it was before the dinosaurs.
The sources of carbon vary by region, but most researchers cite transportation for about 33%. Electric power generation in the US produces about another third. While heating our homes, manufacturing, making cement, agriculture, and clearing forests account for the rest. The result is that the concentrations of CO2, which remain in the atmosphere for 100 years, have increased from 280 parts per million during the Industrial Revolution to 370 today, and it may climb to 500 within our lifetimes.
Now, carbon dioxide is very important because it's a greenhouse gas. Carbon dioxide is also physiologically important. It drives photosynthesis. It controls your blood chemistry. And you are saying we are going to change this by a factor of 2 and we don't expect any consequences? I don't need to understand the consequences in detail to be very concerned that there will be some.